is quite a long question, and it's using various different stats tests. So it introduces this idea that the clinic is testing to see if a new drug gives less recovery time than the older traditional drug. So they've selected some patients, and we have their recovery times in this table. So we have the new remedy and then the old remedy. And we're asked to, if we're going to do a t-test, to state the null and alternate hypothesis. Now, every time you do a t-test, the important thing is to mention that the mean, you have to mention that word mean, is the same for both groups. And then you have to look at the question to see whether it's equal, greater than, or less than for the alternate hypothesis. Now, obviously, we want to see if the new drug is better, so therefore less than the old drug. So you can either write it in words, as I've done here, or you could write it as the mean of the N is equal to the mean of O. And then we want the mean of the new drug to be less than the mean of the old drug. So either of those options would be fine. And then you needed to find the p-value. So for this, you're going to go into statistics and edit. And you can see I've typed in the data here of the two different lists of data. And from there, we're going to go to statistics and tests. And it is a two-sample. We have two samples, new and old remedy, t-test. So we have list 1 and list 2. And then you need to select the right one of these symbols. So we want the new drug to be less than the old drug. So that means that we actually want it to be this option here in the middle. You must always make sure that it is pulled yes, and then we can calculate. So the p-value there is 0.062, which is then what we've written here. Make sure that you write that to 3 significant figures. Even though there is a 0, you need to write that 0 in to show that it's 3 significant figures. And then you're going to state the conclusion. So we're rejecting the null hypothesis because 6.2, if we're testing at a 10% significance level, the p-value is telling us how likely it is that the null hypothesis is true. And that is a very small number. We're only 6% sure that the null hypothesis is true, which is very small. It's smaller than the significance level, and therefore we're not happy with that null hypothesis. So we reject the null and we accept the alternate. And then for part D, we have to explain what the p-value is. So the p-value is the probability that the null hypothesis is true. Okay, so it's the probability that the means are the same. And then the question goes on to say that after a few weeks of using this new remedy, some patients have developed acne, and they want to see if it's as a direct kind of relationship to the new drug. Is it related to that, or is it just coincidence? So this is exactly how a process would work in real life. So we have the data here, the number of people with acne or no acne with the new drug, and then we've done the data for the traditional drug as well. And we're going to see if there's any relationship here. So for this one, we're going to be doing a chi-squared test. We can see here it's a chi-squared test, and again at a 10% significance level. So the hypothesis, every time you do a hypothesis, you need to mention the keywords here are independent and dependent. So you have to mention the words independent and dependent. You can't just say they're related, they're not related, they affect each other, they're not. We talked about this in class. It has to be independent or dependent. And then we can find the p-value. So to do this question, you need to go into the matrix, edit, select 2 by 2, and then type your data in. Once you've done that, and you can see here I've got my data in there, we go to statistics and tests. And this time we're going down to the chi-squared test and calculating. And we can see that the p-value there is 0.0145 to 3 significant figures. And the conclusion of that test So we're only 1.45% sure that the null hypothesis is true. That is very low, and therefore, since it's lower than the significance level, we're going to reject the null hypothesis and accept the alternate. So that means that we think that the new drug and the acne are dependent on each other. So although we found that it did shorten or quicken the recovery time, it also then leads to acne.